All right, so this is 7-4. Tomorrow's quiz is not, this will not be on it. This is 7-4. The quiz will be on 7-1 through 7-3. So make sure you know how to graph using a table, graph using x and y intercepts, and all the information from 7-1 through 7-3. All right, so this is 7-4. So today we're talking about slope. One of the questions that the other class asked, what happens if my points were different than her points? It doesn't matter. The line will still be the same. Okay? So the one thing that we are, just like we did before, remember we used the table method, and then we plotted these points. And here is the equation. Now notice in the equation, we're going to spend a lot more time on this tomorrow, but in the equation, notice where the line crosses the y-axis. Where does it cross on the y-axis? Yes.
1.5 or more than 1. Or negative 3.
The y-axis.
Oh, the y-axis at negative 3.
It crosses at negative 3. We call that a y-intercept. Where do you see that in the equation? Peyton.
It's after x is 2x, it says
Minus 3, right there. Okay, so that is what I call my, right here is what I call my y-intercept. Okay, that's the y-intercept. And you can see that right there in the equation. The next part is the slope of the line. The slope of the line is like the steepness of the line. How I figure out the slope of the line, is I check the change, the vertical change, the change going up and down, and I divide it by the horizontal change, the change moving across, the left and right. Now we use the variable m for slope. I think it stands for some French word meaning mountain. Think of mountain. So it's, see this little triangle here? This is the change in y over the change in x. So in this case, when I go from one point to the next, I'm going to count my, do I do my vertical change or my horizontal change first? Huh? The vertical. Does anybody know what that was from last year? Ben?
Rise over run.
It's our rise over our run. So it's our up and down movement on top of the fraction and our across movement on the bottom of the fraction. So now I'm going to rise how much to get to one point to the next? I'm going to rise 2. Right? I go up 2 spaces to get to the next point, and I put that down as my rise. And I'm going to run how much to the next point? 1 across. 1 across. My running is a cross movement. My rise is up and down movement. And notice on the number line when I go to the right, it's a positive. On a number line when we go to the left, what is that? Because we're losing numbers. When I go down on a number line, it's negative. And when I go up, it's right. So it doesn't matter which 2 points you take. It's always going to be the same. So it's a rise of 2 over a run of positive 1. Now, that simplifies to a 2. So I could write that slope as 2 over 1 or 2. If I'm given a slope of 2, what would my rise be? If I'm given a slope of 5, what is my rise? 5. And what is my run? Because 5 over 1 equals 5. So you can write it as the whole number or the reduced fraction. Now, what happens if I started a different problem? And when I go across, I'm doing my, let's rewrite this. I'm doing my, okay, so I went left 2. What is that, a rise or a run? Run. So where does that go, on the top or the bottom? And I went -2. And now I'm going to go down. Down 4. Where does the 4 go? The down 4? On top. And how do I show that if I'm going down? -4. Now -4 divided by -2 is +2. That equals a +2. So do you see, it doesn't matter which 2 points. When you reduce it, it will always equal. So in order to get a negative slope, what's the fraction going to look like? Notice there's 2 positives in this 2 negatives in this positive slope. Luke. A negative and a positive. There should only be 1 negative in the fraction, either in the numerator or the denominator, to make it a negative slope. Now this is what we call a positive slope. Okay? This is a positive slope. Now, that slope, look where we see it in the equation. It comes right before the x in the equation. So there's my y-intercept, and there's my slope. Yes, David.
Okay, for these problems, like these equations that are only in, I think it's like slope form, I forgot. How much do y equals mx plus c and get the, and like that only for these equations?
Yeah, you have to get the equation where the y is alone, and you can find the slope and the y-intercept. Yes.
Will all the equations be like that?
No, sometimes you can only find the slope and the y-intercept when the y is alone. Once the y is alone, so somebody solved yesterday's problems and got x alone. You're not going to see the slope there. Okay? The y has to be alone. Now, we'll talk more about that tomorrow. It's called slope-intercept form. But today, we're just looking at slope. Okay? So on this problem, what is the rise and what is the run? In this problem, what is the rise and what is the run? And how would I calculate the slope? I see McKenna.
The rise is 1 and the run is 3.
Good. But what happens, okay, and so I'm going to do my run is 1 and my rise is 1 and my run is 3. What happens if I had done this? I started at this point. Let's say I started here. I'm going to go how many? Let's say I went 1, 2. -2 over, which direction am I going in?
You're running it left.
Is that positive or negative?
Negative.
Over -6. Does that reduce to the same thing?
Yes.
I always want the most reduced form. A negative divided by a negative makes a positive. If you do not give me the reduced form of the slope, you will get all fractions should always be reduced. Okay, what's the slope of this? Sarah Tupper.
The rise is 3 and the run is 2, so
Good.
it's 3 over 2.
Good. Now, this is what we call a positive slope. Okay? Think of a slope. We read graphs left to right. I start here and I go here. So in your graph, if I'm just like you read words, you start on this side and you go here. In my graph, I'm starting high or low.
Starting low.
Okay, and then imagine this is your money. Are you gaining or losing by the end of the graph?
Gaining.
So that's a positive slope. Okay, are you gaining or losing?
Gaining.
Are you gaining fast or gaining slow?
Slow.
Whereas here, it's a very steep slope. It's going to be a bigger number. Okay, and it's gaining quickly. This is where you want your money, not here. Okay? Now, what about this one? I start high and I end low. So what is this one going to be, Oscar? What's the slope? Rising?
It's 1.
What kind of one?
Negative 1.
-1 over, and so that reduces to what? Is that going to be positive or negative?
Negative.
Negative. And so notice the way it looks, Luke.
Is the point of rise over run, can't you use that to make like a more accurate line? Like by
Yes.
doing it over-
Yes, for tomorrow. We'll talk about that tomorrow. We're going to use our rise over run tomorrow. But if it's just a slope question, you're going to, if it's just a slope question, you're going to end up, only if they give you a graph are you going to use your rise over run. If they give you 2 points, we're going to use a formula. Okay? So this one,
Losing money rapidly.
right.
Gaining money.
Okay, take a minute, write down the slope. Go. And reduce it. David, let people think around you, okay? Thanks. I know you know. Give me a thumbs up when you're done. You're doing the rise of a run. Okay, I want you to show me with your fingers. Let me do it too. Okay, show me with your fingers what the numerator is. Show me with the fingers what your numerator is. The numerator. Reduced. Excellent. Okay. Now, show me with your fingers what the denominator is. Show me with your fingers what the sign is. Negative or positive?
Wait, the denominator or the numerator?
Either. The whole fraction. Does it simplify to be negative or is it positive? Okay. So you should have had, I'm looking at a bunch of you, you should have had a -2 over a +1 or -2. Okay? Or a +2 over a -1. All right, so now I'm going to move on from this. So we've got a little bit more to do. Okay, algebraically, yes.
How do you know where to go? Like, for the slope, how do you know where to go down?
Any 2 points. Now you're going to pick, that's a good question. I really like that one. Because, let's go here. You go to the points. Now look here. Let's go to this one. No. I just said, which was the one you guys did? Not there.
Yeah.
Oh yeah, that was it. Now notice, very obviously are these 2 points in red, right? You're going to pick a point where it's at the corner of 2 boxes. Okay? There's another point that I see that's at the corner of 2 boxes. Where is it? Sarkis?
The 0.
At the origin. We call that the origin. That's what I used. Any 2 points. So you could have used this one, and this one, or you could have used this one and this one. I personally use this. I went rise negative 2. Okay? And then I went run, positive 1. But look, if I had gone from here, what happens if I go from here? Rise, okay, you need to stop hollering out, sorry. Positive 4. And then what, Oscar?
You go 2 to the left.
Which would be
Negative 2.
over negative 2. The across movement, anytime you go this way or this way, it goes on the bottom. Anytime you go up and down, it goes on the top. Does that make sense?
Yeah.
So it's any 2 points. The slope will always be the same. So when the kids in my first period today said, Ms. Yamasaki, I get different points. I did the whole thing wrong. No. You're going to get different points because there's an infinite amount of points. All of these, this line is made up of an infinite amount of points. You've got a point here, and a point here, and a point here. These are all fractions in here. So I use the ones where the box is at the corner, so I get whole numbers. Did that answer your question?
Yeah.
Okay. That's a big problem in 7th grade. Kids don't know which point or where to start, because especially if they don't have the big red dots on the line. You just go to where it meets at a corner. Does that make sense? Kiana, does that make sense? Okay. Okay, so now, we said slope is made up of a rise over a run. You should write this as we're going. The rise is what we call a change in your vertical. Change in your y-axis, your y movement. And the run is a change in your x movement, your across movement. Now there's a formula. It said you should be writing this as we're going. Don't wait till I'm done. Thanks. The formula, the first thing I do is I name my points. I'm going to say point number 1 and point number 2. And they're interchangeable. I could have called 1, 2 point number 1 and negative 2, negative 3 point number 2. It doesn't matter which one you name 1 and 2. And notice, I use these little sub numbers, x sub 1, comma y sub 1. That means, are you guys seeing this at the lower right hand corner here? X sub 1 means, this is meaning that that's the first x point. And this is the first y point. So what do you think the second point's going to be called? The 1. Yes?
It's going to be 1 and 2.
No, but if the name of the first one is x sub 1, and the name of the second one is y sub 1, what's this one's name going to be? Yes?
It's going to be x sub 2 and then y sub 2.
X sub 2 and y sub 2. Okay? So that's going to be x sub 2 and y sub 2. The sub is just the second x. It doesn't mean squared. Notice it's little, I call it x2, y2, x1, y1. The first x, the second x. The first x, the second x, the first y, the second y. First x, the first y. Do you understand? Yes, David.
So what's the entire formula?
The formula is the change in the y's. The change in the y's. So that's y2 minus y1 over the change in the x's. x2 minus x1. If I start with the second point, then I have to start with the second point in the numerator and denominator. Notice I have the second point here. and I have it here, the first point. Okay, so now what am I substituting in for the second point? What am I substituting in for the second point? Sarkis.
Substituting 1 and 2.
1 for the 2, and what am I, so for the second y, I'm substituting in what? 2. And what am I substituting in for the first y? -3. Now notice it already has a subtraction sign. So you've got to make sure that when you're doing this, you account for the minus sign of the equation and the minus sign of the number, the negative sign of the number. Do you understand why we have those two negatives? All right, so what's going to go on the bottom? What am I going to put down there, Ben?
I have a question about those.
Okay, what am I first putting on the bottom and then your question?
Okay.
What's the second x?
2.
No?
Or, yeah.
Go find it. It's right here. Look right above it. That's the second x. What is it?
1.
1 is the second x. Then what do I write?
The 2.
What about this?
Oh, -2.
Minus, and then the first x is what? -2. So how many negatives am I having in that denominator?
2.
So how should it read?
1 plus 2.
1 minus -2, which makes 1 plus 2. 1 plus 2 is 3, and 2 plus 3 is 5. 5 over 3. And there's my slope, 5/3. That means I have a rise of 5 and a run of 2. Let's see, does it work? I'm rising 1, 2, 3, 4, 5. And I'm running 1, 2, 3. Okay, Ben, question.
Does it matter which one is?
Nope, we're going to do it again. Oscar.
Do we have to show work like that in homework?
No, I'm going to show you what you need to do for homework. When they give you the points, can I go on? When they give you the points, you're going to use the slope formula. You're not going to do rise over run. You're not going to graph it and do the rise over run. You're going to use the slope formula. So every time you do a slope question, not once for the page, but every question where there is slope, you're going to write the slope formula, because soon we will have 15 different formulas. This is how you memorize them. You don't go home and look at it. You write it every time you do a homework problem that involves slope. So in this case, what's the slope formula? I want to hear from somebody new. Yes, Nicole.
X2 minus
From the beginning, I need an equal sign on both sides of it.
slope equals
M equals,
y2 minus y1 over x2 minus x1.
okay. Now, before I do that, I got to name my points. Or actually, I guess they're going to do it now. Now, you want to do it different than my PowerPoint? Let's name, notice my PowerPoint's naming this 1 and this 2. Let's do it the other way. Okay? So I'm going to show you. You're going to compare and contrast. So I'm going to call this point 1. Oops. This is point 1, and this is point 2. So this is x1 and y1. Sorry. For the beginning, start naming everything. x2, y2. So what do I substitute for the y2? Sadat? 3. Then I write minus, oh, positive 7. Good. And what do I substitute for x2. Lucy.
Negative 1
Negative 1.
minus 4.
Good. And now I'm going to simplify that. And I get negative 4 over negative 5. What does that reduce to, please? 4 over 5. So when I reduce it, it will be the same. Now, look here. This time, I named it 0.1 and 0.2. And instead of negative over negative, I got positive over positive. Do you see how it works out? No?
Yeah.
Seriously, I mean, because look, I'm going to go right back. There. So I named this one 1 and this 2. So instead of doing 7 minus 3 and 4 minus negative 1, if I had done it the other way, this is 0.1 and this is 0.2, I'm going to do 7 minus 3 over 4 minus negative 1. And I end up with 4 over 5. See how they work out the same? This is when I have y2 minus y1 over x2 minus x1. Yes?
Did you switch the numbers?
I just switched this. Because I named, it doesn't matter what you name 0.1 or 0.2. It will work out. As long as you make a name for them, and then your bottom line, they should work out.
No, I mean, because
Can I put that question on hold? I'm going to address it, but I want to move on just so I can finish this up before the bell rings. So, the bottom line is it doesn't matter what we name each one. The end point, it will reduce. Okay, now, a horizontal line. Y equals 2. Remember, when I make the table, I'm setting all my y's equal to 2. So 0, 2, 3, 2, 1, 2, and I get a horizontal line. Now, if I take any 2 points, and let's look at a vertical line. Let's say this was all the x's are negative 3, and I pick my y's. So it should cross the x-axis at negative 3. Now, in this horizontal line, your slope is 0. In a vertical line, we say it's undefined. Think of yourself on a snowboard. On a snowboard, your feet are strapped in. I can get from here to there on my snowboard horizontally. From here, where I'm standing, to the chairlift by just doing this, right? Okay? But if I'm at a cliff and I'm going vertically down, will I survive that? No. So you cannot do that. You cannot do that. So you cannot do it. Think of it as being undefined. No slope. This, you're moving from one flat space to another. It's a 0 lift. 0 lift. Horizontal is a 0 slope. Vertical line is undefined or no slope. We use the word undefined or no slope. Now, if you do, let's say you take the 2 points and you do the slope formula. Look what happens. In the horizontal line, we're subtracting. We end up with 0 over 3. And what does that equal? A 0 slope. Okay, if I do that here, what does this equal? There's a 0 in the denominator. Look right here. It's the first of the 10 commandments of math. Thou shalt not divide by a 0. You can never have a 0 in the denominator, ever. It's against all rules of math. You are breaking the first commandment of math. Thou shalt not divide by 0. So, in the fraction form, you'll see the 0 in the denominator. In the If the 0 is in the numerator, that equals 0. If the 0 is in the denominator, it will be a undefined or no slope. That's just picking any 2 points on the line. So this is for all vertical lines. You've got to get to know that those are going to be undefined. Ben?
So when we're finding slope, do we have to write y2 minus y1 over x2 minus x1 every time?
Yes.
Okay.
And I don't mean to be harsh, but these formulas, you're going to start confusing slope, intercept, point slope, standard, and slope. Formula. Especially slope and y-intercept. You know, because they sound the same. The slope formula and the slope-intercept formula. So you want to write those down so you know them. Then we're going to have, you know, a quadratic formula. That's the end.